How could we make something shake if we wanted to? There are a lot of different ways we could do that today, but one of the very first ways humans were able to make a predictable repeated motion was by the use of offset weights on a shaft that we call eccentrics. ERMs are eccentric rotating mass motors, and you can kind of see it inside of this old vintage massager that I found in my attic while I was decluttering today. This is the little weight, and there's a shaft running through here so that when you turn it on, it works kind of like an offset washing machine. There it goes. Yeah, it needs some help. But do you see how when it rotates, it vibrates the thing just like an offset washing machine? And that's what causes the vibration in this little portable deep tissue massager. And it's still used today in a lot of other types of vibrating massage tools that we have in the home, like electric toothbrushes. The electric motor spins a shaft, there's only weight on one end of it, and so it kind of like da-da-da-da-da-da-da. And that's how the haptics on some of the first cell phones worked. It's not the way they work now, as I understand it. Nowadays, there's more of an actuator, which is a back and forth thing. It's not rotational, but this was. Oscillating tools, of course, utilize this, and so do electric shavers. And some of the first vibrational devices that humans were using were to thresh wheat. And through this idea of oscillating motors using offset shafts became camshafts and crankshafts. Crankshafts are how we turn up and down energy into wheels turning. If you've ever seen a cylinder go down and be connected to two rods, and the rod down here is connected to a circle, so that when the cylinder goes down, those two rods kind of articulate and turn up and down motion into rotational motion. And that's kind of a descendant of the oscillating, eccentric rotating mass. Also, cams are related. That's a shaft that instead of having a perfectly centered round disc is a little bit offset. So every time this rotates and flops in a predictable rhythmic manner. As the shaft rotates on that offset plate, the cam, there's a little follower on the high end. So as it turns, that little follower is following it. That little follower follows it and can act as a timer. And that's how engines' valves know when and how to open up. These are the little things that I like to talk about because, you know, this whole thing is like a little bit hard to understand and daunting, but the individual components are actually really easy to understand, and I think they're really cool. Just like having a straight shaft with a weight on one side of it, and as it turns, it wobbles and flops, and we learn to harness that for what we need. Cool. So like, it's not even a simple machine, it's just a thing. A general idea for a tool you have at hand to do work that you might need to do. It's like knowing that you can compress a spring to store energy and knowing it's going to shoot out when you let go. Knowing that you can use tension, the idea of tension, to do work for you. It's like knowing if you're gluing your shoe together and you need to be able to like stick the sides of the sole because it's peeling apart from the glue, you can wrap rubber bands around it because the compression strength of those rubber bands is going to hold your shoe in place until the glue dries. Like tricks, mechanical tricks. I like mechanical tricks.